Next problem. Now, in an effort to make this fit on one page, I didn't put a lot of room here. So we're going to do this one down here on this separate sheet of paper. Same process. We're going to go through. We're going to decide which law to use by making our list, and then we're just going to plug in our numbers. An air-filled balloon has a volume of 225 milliliters. So volume is 225, liters. And a pressure, got a pressure of atmospheres, 0.94 atmospheres. And we have a temperature, 25 degrees C. Again, everything has to be in Kelvin, so let's go ahead and add 273 to that to give us 290 Kelvin. Soon after, so these guys all happen at the same time, so let's call them 1. The pressure changes. Oh, new pressure. Pressure 2 is 0.99 atm. Got that right there. And the temperature changes to 0 degrees C. So temperature changes to 0 degrees C. Now you can really see why we need Kelvin, because then we'd have a 0 in our denominator in this next problem, and when you put a 0 in the denominator, it's bad news. And it says, what's the new volume? So it wants volume 2. So now we have a list. We can go ahead and go to our list of things, and the only thing that has all three things changing and keeps the amount of gas constant is the combined gas law. So pressure 1, volume 1, temperature 1 equals pressure 2, volume 2, temperature 2. We're going to solve for volume 2, so we're going to take this guy and we're going to move it down there. We're going to take this guy, we're going to move it up here. Volume 2 is equal to pressure 1, volume 1, temperature 2, temperature 1, pressure 2. Notice that pressures will cancel, temperatures will cancel, left with the volume. That's what we want. And then we should write out all our units as well so that we can see that everything is canceling but the liters. So pressure 1 was 0.94 atm. And volume 1 is 225 milliliters. And then temperature 2 is 273 Kelvin. Put that over temperature 1, 298 Kelvin. Now you can see our Kelvins are going to cancel. And then we have 2 at 0.99 atm. And now you can see our atm, and we're left with liters, not milliliters. See, it says liters over here. So now what should the, pressure volume have an indirect relationship. One goes up, the other one goes down, where temperature, pressure, and temperature volume are both direct. Our temperature changed a very little bit. It went down, so that should make volume go down a little bit. And our pressure went up a little bit, which should make our volume go down a little bit. So let's see what we get. Now, that's tricky when you put it in your calculator because of these two guys here at the bottom. That's a very common mistake students make. And so now I'm going to hit enter. That's all the top. And now when we hit divide, we want to make sure it's in parentheses so that we can divide both these numbers after they have multiplied by each other. And we get 195.7. So let's just round that up to 196 liters of this gas. Combined gas law.